Okay, Haley, will you remind me again which ones you wanted?
11, 12, and 20.
11,
That's
12.
the same ones I needed.
Perfect. All right. 11. Says sketch and label a square pyramid with height 8 feet and each side of the base m feet. Alrighty.
Somewhere 11.
This is number 11. Yeah. So I'm going to make the base look like that. Okay. Height 8 feet and each side of the base is m feet. So those are m. The altitude meets the square base at the intersection of two diagonals. So the two diagonals would cross right in the middle. So I need to make a height straight up from that. And then if I connect all of those to the top of that, then there is my pyramid.
Super cool.
Okay, hold on, I'm going to make this,
Figure out how to draw this thing.
Wait a minute, what are you doing?
I want to make that a dotted line. Okay, so there's the pyramid. 100% perfect. And it says the height is 8. The altitude meets the square base of the intersection of two diagonals. Find the volume in terms of h and m. So what is the formula for the volume?
1/3 big base.
Yes, I am 1/3 big base times the height. What's that? Please. What's the area of the base? M squared. And what's the height? H. I was hoping that was going to make another funny thing like when the other one was QT pi, but I guess not. 1/3 m squared h. Okay? That's that.
Yeah.
All right, and then you need 12. Sketch and label 2 different circular cones, each with a volume of 2,304 pi. Can I get rid of this stuff?
Yeah.
You guys have that okay?
Thumbs up.
All right, so sketch and label 2 different circular cones, each with the volume of that. Okay, so to start with, we need to sketch the cone. So to give it a little perspective, I'm going to put it's just an oval on the bottom. And then make it a cone. You happy about that?
Can you write dunks on it? And then make it work.
Aren't you supposed to do like a dotted line?
For the height?
No, for the back side of it or something.
No, I think that's all we got for a cone. It's just why is it tilted a little bit? Yeah, it's tilted towards
Is
me
that
a
all it
little. Yeah, so there's the circular cone. Now we need to figure out, oh, Jennifer, I know what you're saying, for the radius too.
We have to make another one.
Okay, we have to make another one. You mean we get to make another one?
No, I mean we have to make it.
Yeah, I'm gonna make this one different.
Still leaning towards you.
That makes perfect scale.
Oh, you got like a gravitational pull?
Yeah, I do have a gravitational pull. Everybody does.
Yeah.
Okay, so
We got a strong
now we need to figure out some dimensions to make that be the volume that we want it to be. Okay? So let's just start by doing a guess and check here. Give me a radius.
20.
2.
6.
Okay,
No,
so
let's
this
go with.
radius is too
Let's
late.
go with 8.
Nope, it's too late. We'll do 8 on the other one, Nick.
Oh, I said 6.
All right, so if this radius is 2, and you can see right away we're not drawing the scale, what would the area of this base be?
2 squared. 2 pi. 4 pi.
4 pi. And so if I want the volume to be 2,304 pi, how would I figure out what the height has to equal to make that work? I'm going to go backwards. Right, so I'm going to take the formula, which is area of the base times the height divided by 3. And I'm going to say the volume is 2,304 pi The area of the base is 4 pi. We're trying to find the height and then divide it by 3. So how do I solve that for h?
Divide by 4 pi.
Cancel the pi's.
And then multiply by 3.
Multiply by 3, so this would be 6,912.
Divide by 4.
Good, and then we divide by 4.
For each.
Divide that by h. 4 goes into 6 one time. It goes into 28. It's what?
1,000.
Okay, 1,728 would be the height. So this one is definitely not drawn to scale. If this is 2, then that's
But that's not.
1,728. Okay? All right, so let's do that same thing here with this one. What would the area of this base be?
64.
64 pi, not 16. You're squaring it, not doubling it. All right, so then I'm going to do the same thing. I need the volume to equal 2,304 pi. So 2,304 pi equals 64 pi times h divided by 3.
So you multiply by 3.
So I'm going to cancel the pi's and then multiply by 3. So this is still going to be 6,912 equals 64 times 8.
108.
Even?
Yep.
Nice. So the height in this case would be 108. So we were able to randomly guess numbers and it came out with a whole number for the height. That is pretty freaky. Okay? 20? All right, number 20. So yesterday when we were talking about volume, we talked about a couple of different oil spills. We talked about the Exxon Valdez oil spill, and we talked about the oil that was spilled during the Gulf War. So now our lives are getting even worse. It says, as bad as tanker oil spills are, they are only about 12% of the 3.5 million tons of oil that enters the oceans each year. The rest comes from routine tanker operations, sewage treatment plants, runoff, natural sources, and offshore oil rigs.
Wow.
1 month's maintenance and routine operation of a single supertanker produces up to 17,000 gallons of oil sludge that gets into the ocean. If a cylindrical barrel is about 1.6 feet in diameter and 2.8 feet tall, so this is a barrel that they store oil in, and it is 1.6 feet across.
That's a beautiful barrel.
Thank you. And 2.8 feet tall. How many barrels are needed to hold the 17,000 gallons of oil sludge? Recall that a cubic foot is about 7.5 gallons. Okay? So the first thing we can do is if we know that this is a total of 17,000 gallons, and we know that 1 cubic foot equals 7.5 gallons. How many cubic feet will these 17,000 gallons take up? 7.5.
Hey, do you design these barrels? Because I think we found the source.
What?
2,266.6.
2,266.6 repeating. Okay, and 2/3 cubic feet.
What do you round up?
I'm going to wait till the very end to round. Okay, so that's how many cubic feet of oil I need to store, basically, in these beautifully designed storage containers. How do I figure out the volume of this? If we-
0.8.
Okay, good. We want the radius, so if the diameter is 1.6 feet, the radius is 0.8 feet.
0.64.
All right, so that means the area of the base is 0.64 pi, because 0.8 times 0.8 is 0.64,
How?
and then times it by what?
By the height.
So the volume is the area of the base times the height, which is 0.64 pi times 2.8, which is
1.79.
pi. Okay, so 1.792 pi, all right? So that's how many cubic feet of oil we can store in one of these barrels. How do we figure out how many barrels we need if this is a total of 2,000?
Divide it.
What's that?
Divide it.
Divide it. So I need to divide this by 1.792 pi. Let's figure out what this is without the pi in there first. Okay? So multiply that by pi for me, will you, Haley?
5.6.
5.6?
Yeah.
Okay, so that's really 5.6 cubic feet of storage that they have. So 2266.666666666. It's repeating. Okay? Aaron, are you with us? Are you okay? What you got going there that's more interesting than what I'm doing up here? Calculator.
No, I lost my.
Can you give me any of these numbers? Is that what you're doing on your calculator?
Alright, I'm a little slower there.
Oh,
that's
okay.
it.
All
I
right.
am not texting someone, Cole.
Sorry, I'm not bullying you. Not bullying you.
Aaron, let's make sure that you're only using your cell phone for a calculator, okay? 404 point what?
7.
Okay, and so now Manuel said at the very beginning right here that he wanted me to round up because we want to know total number of barrels. And I said we're going to wait till the end. And so when we get an answer of 404 point what?
7.
Okay, then we're going to round that up to actually 405 barrels. To store all that oil, okay? Did you come up with that? There, yeah, you get that? Okay, just a little slower than the rest, that's okay, as long as you get there eventually. Hale, everything okay? Yeah. Okay, thanks. Okay, do you guys need anything else? Maybe one more?
Turn them in.
We're good? 18.
Oh my goodness.
Oh, just be
I
nice.
need number 8.
We did like 4
I'm just saying that barrel is definitely the source of all that leakage.
Number 8.
Yeah, let's take a look at 18. This is very complex, okay? All right, we'll do this last one. It says a swimming pool is in the shape of this prism, and then like we did in the other problem, 1 cubic foot of water is 7.5 gallons. How many gallons of water can the pool hold? So how are we going to figure out this problem?
Skip it.
Okay, you want to divide it up into different sections? How did you do it? Across or down? Okay, hey guys, we're not quite done, so just shh. Really, from you. So we're going to divide this. So we're going to divide this across this way. Okay? So let's make one more. So that is going to give us 2 different shapes. This one, the one on top, is easy to find the volume of because we know this dimension is 4, we know this dimension is 30, and what's this dimension right here? 16, right, because it's the same thing right there. So the volume of that is 4 times 30 times 16, which is, got that, Aaron? 4 times 30 times 16?
1,900.
Oh, Manuel beat you again. What? 1,920. Okay, so that comes out to be 1,920 cubic feet. Okay, this one is a trapezoidal prism. So I need to find the area of this trapezoid right here. So to do that, I'm going to add the 2 bases. So 30 plus 13 is 43. And then I'm going to multiply it by the height. Now, what's the height right here just of the trapezoid? Yeah, I'll do that in the end. What's the height?
4 minus 14.
Which is 10. Okay, so this trapezoidal thing right here is going to have a height of 10 because the whole thing is 14. This much is 4, so that is 10 left over. So 30 plus 13 we said was 43 times 10 is 430. And then Manuel says we need to do half of that because it's a trapezoid. So that's going to be 215. And then again, I'm going to multiply that by the height of the prism, which is the distance in between those 2 trapezoidal faces. So I'm going to multiply that by 16. So, thank you. Say that one more time.
3,440.
Okay, so 3,440 would be the volume of this bottom part. Okay. All right, so if I want the volume of the entire pool, I need to add those together. So 5,360 is the total cubic footage of the pool. So how many gallons is that if every cubic foot is 7.5 gallons? Are we going to multiply or divide? Every cubic foot is 7.5 gallons, so we're going to multiply by 7.5.
40,200.
40,200 even?
Yep.
Fun. Okay, so that's 40,200 gallons of water. Okay? All right, now for the second part of this, if they can pump water into the pool at a rate of 15 gallons per minute, how long will it take for them to fill the pool? Yes, now we're going to divide. So take this and divide it by 15. Bless you.
Thank you.
Say that one more time.
2,680.
2,680 minutes. How many hours is that?
I don't know, divided.
Divided by 60.
44.6.
44 and 2/3 hours. Okay, so it'd take almost 2 days nonstop to fill that pool. Okay. Must be-
Figure out how much it's gonna cost if it's $1.50 a gallon.
Can you figure out how much it's going to cost?
Yeah.
That would be like $60,000. Okay, but water doesn't cost about 50 a gallon when you use it in your house.
You just go to the hose.
Yeah, I mean so that means if you fill it up with water from like the grocery store, it costs that much. I mean, people would spend more to swim in your pool if you were like, oh, it's bottled water swimming pool. Maybe that's the next new trend. Yeah, exactly. So you can drink it while you're swimming.
Nasty.
Yeah.
People
All right, you guys pass those forward, please, and then we will have our quiz.
Wait, this water's not chlorinated?